Hi guys, today we're going to talk about angle relationships. And I almost wish that this section was the first section because a lot of this stuff we kind of already talked about when we were identifying angles. So this might be a little bit review, but we're really going to practice with the vocab today. So these are the words that we hope to know pretty well by the end of the lesson. Adjacent angles are angles that share a common ray and a common vertex. We said that those guys were next to each other, remember? So we were talking about angles like this. Here's an angle. And then if I make a blue angle, has to share a side and a vertex. So it's to share a ray and a vertex. So this angle and this angle are adjacent. Now I could have gone on the other side as well. I could have shared this side. Oh, that's still blue. I could have shared this side and gone over here, and that could have been adjacent. So these two are adjacent, and these two are also adjacent. Okay, complementary angles we did not talk about a lot, but complementary angles are two angles whose measure have a sum of 90 degrees. So when you have an angle that's 30 degrees and an angle that is 60 degrees, we can say that those are complementary because they add to 90. A lot of times they will be adjacent, so you can tell they're complementary, and they would have the little box here, and you would know that they would add to 90 degrees. Congruent, which has a nice little symbol that looks like this, means that they have the same measure or equal measure. Well, you don't want to say having the equal measure, doesn't really make sense. Okay, so if you have two 30-degree angles, those have the same measure. And a way you can show that they have the same measure, if they don't have the 30 inside of them, is we can make a little arc. And if we show that they have an arc on each of those, that means they are congruent. Linear pair we talked about, those are adjacent angles, so angles that are next to each other that form a straight line. And these are nice because straight lines add to 180. So this is a linear pair. They're right next to each other, and they form a straight line or a straight angle. These are also supplementary, which are two angles whose measure have a sum of 180 degrees. The difference between supplementary angles and linear pair is that supplementary angles don't have to touch. They can touch, but I could have drawn these separate like this and this. And these two are also supplementary. If I said this is 120 and this is 60, they're supplementary because they add to 180, but they're not a linear pair because they don't make a line. But these two are a linear pair and supplementary because they have to be adjacent. And then you know what the vertical angles are. We call those the kissing angles. They're opposite congruent angles formed by two intersecting lines. So if you have an X, the vertical angles are congruent. This guy is congruent to this guy, and then the guy on the right is congruent to the guy on the left. And I put 2 marks there because these two are congruent, but they're not necessarily congruent to those two. So I did 2 marks instead of 1. Okay, now we're going to classify angles. So there are 3 things that angles can be, 4 ways that angles can be classified. They can be acute, and acute angles are less than 90 degrees. And you can remember that because what do you say when you see a little baby? Oh, it's a cute little baby. These are little angles. You know this one. This is the right angle. It equals 90 degrees. You know that it's a right angle because there's a little box there. This is obtuse, and these are big angles. It's more than 90 and less than 180. You can remember this because of the prefix OB. Also, the word obese means a big angle. Obtuse is a big angle. Obese doesn't mean a big angle. It means an overweight person. And this would be a straight angle. And straight angles equal 180 degrees. Okay, so those are the types of angles. We have acute and obtuse. Those are the big ones. Right and straight, kids usually know pretty well. Okay, so how many angles can you see here? Because some of them are hiding. Okay, there are 6. So let's see if we can find them. We name angles by using 3 letters. So highlight them as we go. The first one I see is angle ABD. ABD is right here. Okay, another one I see is DBE. Angle DBE, that is adjacent to the one I just said. DBE. Next, I see EBC. Now, those are the three that are obvious to see. So where are those other hiding ones? Okay, well, here is one. We have a big outside one, angle ABC. That's a big outside one. What else do I have? Well, I can skip a line and I can go from A, B, E. And I could do that the other way, and I would have angle DBC. Okay, now what if you traced it the other way? Yes, that's perfectly fine. There are two ways you can name these angles. You can say ABD, or you could say angle DBA, but those aren't different angles, those are the same angle. So what happens here? Well, they're talking about adding angles to get other angles. So let's see what we have here. Angle ABD, and when they have the M there, that just means the measure of ABD. So I have ABD, and I add to that angle DBE. What angle do I have? So if this was 30 and this was 40, that would equal 70. Well, what angle would equal 70? That's the big outside angle, which is angle ABE. This is basically saying a little angle plus a little angle is going to equal the big outside angle. And we're going to try that again. So on this one, it says ABD. If I add that to DBC, what am I going to get? Well, what's the big outside angle? That would be this one, ABC. So inside plus inside is that big outside angle. So now we're looking for adjacent angles, ones that are right next to each other and they share a side and a vertex. So let's see what we have. AFB, is that adjacent to BFC? Do they share a side and share a vertex? That is a yes. Let's try the next one. Oops. How about AFB and CFD? They shared a vertex, but did they share a side? No, those are not adjacent. Next, I have BFC and CFD. They shared a side, they shared a vertex. Are they adjacent? Yes. Now we have BFC and DFE. They shared a vertex, but not a side. Those are not adjacent. And the last one for us to check is CFD and DFE. Share a vertex, share a side, they are adjacent. Okay, let's talk about linear pairs. So if you have lines that cross, we got some vertical angles here, and we have some linear pairs, which would be supplementary. So what are they talking about here? Angle MXN, which is right here, and NXP are adjacent angles that form a straight line. So when you add those two, what would you get? Since they make a straight line, well, what do straight lines add to? That equals 180 degrees, which is also the same thing as MXP. Because MXP is a line, we call that a linear pair. What are some other linear pairs in the diagram? Okay, so another linear pair would be QXM And what one makes a linear pair with this? Well, there's two. If I go this way, that would be angle MXN. Or I could have gone the other way, and I could have had a straight line over here, which is angle QXM and angle QXP, because there's a straight line either way that you go. And there should be one more straight line, I would think. What would this one? MXN and NXP. How about MXN and MXQ? Did we do that? MXN and MXQ we already did. MXQ, and we didn't do this bottom one. Let's do this bottom one. Okay, the last one is QXP. And what makes a straight line with that is NXP. Okay, so you're looking for straight lines and two angles that make a straight line, and we're going to call that a linear pair. Vertical angles are the kissing angles. They are not adjacent, so they only share the vertex. So what do we have here? AMX, and that one goes with AMX. Which one does it kiss? Angle YMB, which is this one. And we know that they're congruent. I can show you they're congruent by putting a little arc. There's another pair, the top and bottom, angle AMY and angle, and I'm going to put 2 here, XMB. And I'll put 2 there to show that those are congruent, because vertical angles are congruent. Two angles whose measures have a sum of 90 are complementary. They don't have to touch, but they can. If they are adjacent, they would form a right angle. So these two are complementary. They're not adjacent, but they're still complementary. This is a bad diagram, but since the diagram is bad, even though 60 plus 30, that should equal 90 degrees. They should form a right angle, even though the picture is garbage. Let's look at this. Two angles are supplementary or add to 180. And if they're adjacent, they would form a linear pair. So these two are supplementary and they're not adjacent. They don't touch, but they do add to 180. And these guys form a linear pair. So they're also supplementary, but they just have a special name. So let's find, how am I doing here? Got quite a few more. Okay, let's see what we got. Intersecting lines form two types of angle relationships. We have adjacent angles and vertical angles. Adjacent angles are just the ones that are next to each other. They'll form a straight line, and you can see what their measures are here. We have 40 and 140. The vertical angles are the ones that are congruent, and those would be the 40 equal the 40 and the 140 equal the 140. These guys, add them together and you get the 180. So if you have crisscross lines, if you know one of them, you will know all of them, because you can use your 180 trick and you can use your vertical angle trick. So let's practice doing some puzzle solving. We did some of this the other day, so let's continue to do that. We're just finding missing angle measures. So first thing, they're asking me for CFD, but we don't have to do things in the order they tell. Let's just go what we see feels good. So if this is 50, right away you should get good at finding its vertical angle that's kissing it, which is this guy, which is 50. BFA is 50, and I'm going to do this last one first. We never let them boss us around. Now we have some straight lines, and they add to 180. So you can find this guy here if you want. Some of you might find this guy. It's up to you. Straight lines add to 180. Here's a linear pair. If I take 180 minus 50, I get 130 for angle AFE. So this would be 130. How about this guy? Well, I can use the straight line, add to 180, or if this is 90, this has to be 90, and they would be complementary. So you can take 90 minus 50, which is 40. The other thing you could have done is use the whole straight line. You could have taken 180 minus 90 minus 50 to get the last one, which would also be 40 degrees. Lots of routes you could take on those problems. Okay, let's see what we have here. You have railroad tracks meet some streets like this. This is a right angle. The town is allowing a company to build a train stop at angle S. If S is the measure of angle S is greater than 40. So it will only let them do it if it's bigger than 40. So is it bigger than 40 is our question. Well, let's see what we have here. This is a straight line. This is 90 and this is vertical. These two are vertical. So you can either put the 40 here if you want, or you can drop this 90 down here because those are vertical. These are don't have measures yet, so we can't use the vertical angles here, although this would be the same thing as S. We really need to figure out what S is, so we're going to use a straight line. Straight lines add to 180, so I could take 180 minus 90 minus 40, or you could just take 90 minus 40, and that will give you 50 degrees. So angle S is 50 degrees. So can the train stop be built there? Well, is that greater than 40? Yes. So the answer is yes, it can be built there. Okay, one more puzzle problem. Let's see what we can do here. There's no vertical angle here. This is not vertical. I have to make a perfect X, but these guys are vertical. So I can put a 65 here. So what's that? BPD. BPD is 65. Straight lines add to 180. So I think I'm going to use a straight line add to 180 here. Or you could use the right angle marker here and take 90 minus 65. That's up to you. That's 25 degrees for angle CPE. What's left to find? This big one here, APD. I guess I could have gone right there right away. There's a straight line. Straight lines add to 180. 180 minus 65. It's 115 degrees. Some of you might have done that first. Like I said, it doesn't matter the order you go on those. Okay, so we're going to wrap some things up here. What angles share a common ray and vertex? Those are called adjacent. What are adjacent angles that form a straight line? We call those linear pair. Angles that are opposite and congruent, we also call those kissing angles. They're vertical angles. Complementary angles add to 90, and supplementary angles add to 180. Okay, that's it for these notes on 2-2. Let's do some practice with this vocab.